Before we welcome Alice, our speaker, to the stage tonight, I'd also like to pay my respects personally to the traditional owners of the land. I, as you can tell from my accent, I'm not originally from this area. I grew up in the north of England, and I was mad about astronomy since I was about knee-high. I've always been fascinated by this subject. And I grew up devouring all the knowledge and wisdom that I could that had been passed down through the generations. And where I grew up, that was a couple of thousand of years of knowledge, really. When I was learning about stuff, we didn't go much further back in time than the Greeks and the Romans. And in terms of the astronomical knowledge of my own country, of the UK, we really didn't go back beyond the Battle of Hastings in 1066 and those views of Comet Halley that I showed in the talk last night. So we've got a depth of knowledge there that's fairly shallow. And so it's an incredible honour and privilege to me, as someone who comes from that kind of background, to move over here to Australia to get to work in the country that has the longest continuous history and heritage of astronomical research anywhere on the planet, and to actually get to work with some of the people who are leading that work from the Indigenous population. We've got some incredible scientists and communicators coming from that community doing incredible work. We've got a history and a heritage here of more than 70,000 years of astronomical knowledge and wisdom that has been passed down primarily through oral history. And to me, coming from the background I've got, it's such an honour and a privilege. It's breathtaking to be able to learn from that, to work with those people. And I think it is very important for me personally, therefore, to pay my respects to elders past, present and emerging from all across Australia, but particularly the people whose lands we're on today, the Gayabal and Jarawai people. So I do like to pay my respects. With that said, I would like to welcome to the stage Alice Gorman, Associate Professor, I believe, at the minute, or full Professor. Alice is a world authority. She's a fabulous researcher who does all sorts of things in both archaeology and what we're talking about tonight, space archaeology. One of my great heroes since I've moved over here. So it's wonderful to get to introduce her. She is also recognized globally for this by having an asteroid named after her. Her asteroid is number 551014, and it's about a 2-kilometer lump of rock or metal floating around between the orbits of Mars and Jupiter out in the asteroid belt. So that's Alice's real estate, and this is Alice in person. So I'll hand over, and thank you for paying attention. Thank you.
Thank you, Jonty. Jonty and I are asteroid siblings because we both have an asteroid named after us, which is quite a special and wonderful feeling. So I'm very happy to be here in Toowoomba with you tonight, and thank you, Jonty, for asking me to be part of the Festival of Astronomy and Space. So I'm going to talk to you a bit about space archaeology and a particular perspective of the solar system, I guess. Now, can everyone hear me fine? Excellent. And I believe that we will have time for questions afterwards. So this is the topic of my talk tonight. It is about the archaeology of an inhabited solar system. And I'll start by briefly explaining what space archaeology is, because often when people see those two words put next to each other, it can be a little confusing. Generally, archaeology is thought of as the study of the deep past, and space is very much in the present and even in the future. So how can you do an archaeology of space? And the simple way to explain that is archaeology as a discipline isn't really about old things, although a lot of the time it is, but it's actually a set of theories and methods that we use to try and understand human behaviour in relation to the material world. So how humans use objects and environments and buildings and architectures in order to create culture, and how that culture changes and adapts over time. So if you look at archaeology in that way, you can basically do an archaeology of any time period, including the present, and you can do it in any location in the universe, including outer space. So that's basically what space archaeology is, and I'm going to consider some particular space archaeological places and sites a bit further in this talk to demonstrate this. So I'm talking about an inhabited solar system, obviously. That solar system is this one that we're living in right now. It is the only inhabited solar system we currently know of. And this picture is just to remind you what that solar system consists of. So this is obviously not to scale. Jonty, that's like a logarithm scale, isn't it? Yep. But it's to, so otherwise you'd never fit everything into the same picture. But you can see on the far left, you can see the sun. Earth is located just here, and that distance there is known as 1 astronomical unit, or AU. Then we go through all of the other planets until we get to this interesting region. This is where the solar wind meets the interstellar wind. And the Voyager 1 and 2 spacecraft launched in 1977 are currently outside that boundary. Now that's often considered to be the end of the solar system, but it kind of isn't, because beyond that, we actually have this thing called the Oort cloud, which I believe is still theorized but not proven. However, there are these long orbit icy comets which appear to come from this general region. So I believe we have some evidence to suggest that the whole solar system is surrounded by this sphere of these little icy bodies, which I think it's about, it's enormous. Anyway, I was going to say 300 light years across. No. Anyway, there's a big number involved in that. So you could really say that the solar system technically ends somewhere outside the Oort cloud, and these are among the nearest star systems to us. So we're going to be concerned primarily with all of the artifacts, all of the human-made materials which span this distance in here. So normally, if I were going to be talking about space archaeology, it's quite likely I would start on the surface of Earth. I'd say, here are the places where people launch rockets from, and here's what's happened to the rockets. They go into Earth orbit, they go further out. But tonight, I'm going to be looking at our solar system as if we're approaching it from outside. And I'm going to think about how we might comprehend or ask questions of the stuff that we find along the way as we go closer into the heart of the solar system, get closer and closer to that sun. And of course, if we're lucky, because these are needles in haystacks on a cosmic scale, one of the first material objects we might find would be the Voyager 1 spacecraft. So out beyond that, the heliopause, where the sun and the interstellar medium crash into each other. So it's been traveling since 1977. It's estimated that its batteries will last maybe till the end of the decade. And one of the places that listens to Voyager 1 and Voyager 2 signals is the Tidbinbilla tracking station just outside Canberra, one of 3 places that are listening for Voyager 1 and 2. But in a not so very big number of years, its little voice is going to fall silent. And it'll still be out there, but we won't know where it is or what's happening to it. So as the first object that an external visitor to our solar system might meet, it's quite an interesting one. Some of the things you might note about it as an artifact is that it has this very long magnetic boom. It also has down here, this is a power source, which is plutonium-238, a radioactive form of plutonium. And on its little body here, I'm not sure if this plate, this is clearly an artist's impression, if this bit here is meant to represent it, it has a golden record. And these are the things that fascinate people the most about Voyager 1 and Voyager 2. On the golden records, each one has one, there's 90 minutes of music, which includes 1.5 minutes of Aboriginal music from Milingimbi Island in the Northern Territory. And there's 160 photographs, and there's greetings spoken in a whole bunch of languages of the Earth. So it's meant to be a little snapshot of human culture at that time for people who might find it in the future to interpret. So there's a lot going on with this spacecraft, the cultural stuff, the technological stuff. But one thing of interest about it to an outside observer is that it is fleeing from the solar system. It is leaving the solar system. So what would you make of that? Might you ask the question, what is it fleeing from? So let's keep going deeper in. The next human object we might come across would likely be this one. This is the New Horizons spacecraft. It's currently in the Kuiper Belt somewhere. I think it's visited at least 2 Kuiper Belt objects, which tend to be rocky, icy sort of little things. You can see it's similar to Voyager 1. It has a dish antenna. It's got a nuclear power source. I think, again, it's plutonium-238 in this. It's got a very different body shape, a little sort of chunky triangular body shape. And it's also got a thermal insulation blanket on most parts of it that are visible. Although likely by now, this would be very tattered and torn, having been exposed to bombardment by all the particles and micrometeorites that are out there. But we're never going to be in a position to find out. So 2 very similar spacecraft, both moving outwards, both leaving the solar system. So we move deeper in. At this point, if we wanted to look in towards the sun, this is what we might see. So this is a very famous image taken in space. This is 6 billion kilometers from Earth. And this is when the Voyager 1 spacecraft turned its camera back towards the Earth and photographed the pale blue dot. So at this point in our journey into the solar system, this is the scale at which we would be observing Earth. Now, interestingly, Jonty told me I could have as much time as I liked, so this might be his famous last words. Interestingly, the brightness of Earth has changed a fair bit over recent decades. For a while, it was getting brighter, which means that you might have seen a slightly brighter or even slightly larger dot from this vantage point. At the moment, it seems it's getting dimmer. So maybe this view would no longer be possible from 6 billion kilometers out. So I expect this is probably something that's going to change, continue to change over time. So this is where we are right now at that point, but we'll keep moving in. And but now we start to come across the first planets. Now I know Pluto's, Jonty's shaking his head. I know Pluto's not technically a planet anymore, but I don't care. For me, it will always be a planet. So this is the largest, roundest, biggest planet-like thing that we've seen so far in the solar system. The question is, are there any signs or artifacts made by some kind of technological species on this planet? And it's 6 moons. And in our little survey spaceship, we cannot find any evidence that anybody has lived on this surface of Pluto or its moons. There's nothing in orbit. If maybe we might have instruments sensitive enough to catch a few little weird molecules in a wake that was left by New Horizons flying by in 2015, maybe not. So from the perspective of looking at its archaeology, Pluto is interesting in so many ways, but it's not interesting to us for that reason. So we keep going further in. The next planet we reach is Neptune, which is known as one of the ice giants. And this image is an amazing image to me. This was taken by the James Webb Space Telescope just last year, I think. So this is the latest, highest defined image we have of Neptune and its ring system and some of its moons, which you can see in that image. And there are 14 known moons of Neptune. But there's no evidence of any human activity, any signs of technology or life. So as beautiful as it is, we will continue to move on. The next planet we come across is Uranus. And depending on the age composition of an audience to which you may be speaking about this planet, some people choose to modify their pronunciation. I do not choose. So this is Uranus. And it's another ice giant. It has extremely fast winds, so does Neptune. It has a beautiful ring system. It has 27 moons, but we don't see any evidence of any kind of culture or technology in the region of this planet. So we forge ahead. The next one is Saturn, a planet beloved of humans for its spectacular ring system. And the most recent studies have shown that Saturn has 145 moons. The moons are interesting because even if a planet doesn't have a structure which enables it to have a solid enough surface for anything like life to evolve, or for people to potentially land on and carry out experiments or build some kind of habitat, often the moons are going to be potential sources of doing that. But we don't find anything, we don't find anything much, because there have been some missions to Saturn, Cassini being the most famous, and in fact one of the moons was the target of exploration, the moon Titan. So this is an artist's impression of what the Huygens spacecraft that was dropped onto Titan in the Cassini mission looks like. So let's think of it in comparison to those two previous spacecraft we've seen, New Horizons and Voyager. This is the first landing craft, the first technological object we've seen on the surface of another celestial body. You can't see them here, but it also has radioactive power sources. And it's like this little sort of hard shell, like this little sort of beetle-y thing. Titan has an atmosphere very high in methane, and the main materials this spacecraft is made out of are aluminium or aluminium alloys, which are unreactive with methane. So there is a strong possibility that it survives in good condition. The parachute, which you can see over here, maybe not so much, but certainly this spacecraft and its little antennas and all the things inside it. So it's quite different to our sample of now 3 artifacts that we've found in this inhabited solar system. But the big question is, who is making these things? Where do they come from? And what do they mean? So we find another celestial object which has artifacts on it, but this time it's a comet. In particular, the comet 67P Churyumov-Gerasimenko. What we see on this comet is radically different to the 3 things we've already found, which you will remember, New Horizons and Voyager 1, not so dissimilar to each other, both in deep space heading out. Huygens and what we're seeing here is Philae and Rosetta are now a surface. We've got 2 surface examples now, but this one, there's no radioactive fuel. This is all solar powered. These are the first solar panels that we've seen. And this is quite a complex place. There's more than one object. We have the Philae lander, and probably now you wouldn't see it. It bounced. The landing went quite badly wrong, and it bounced on the surface. And those marks might have survived for a little while, but it's quite an active place. So probably now you wouldn't see any evidence. You'd just find the lander itself wedged in under a cliff. And Rosetta, which we see up here, was crashed into the comet fairly slowly, sort of at walking pace, but still those solar veins have probably broken up into their different panes. Some of them might have bounced off. There'll be a little crater, and the very active surface is likely tarnished and weathered. You know, the beautiful blue that we see in the artist's representation of the solar panels. So these are all very different spacecraft. It's hard to get a sense of a unified culture by looking at these. But we go on. We're looking at the gas giants. We visited Saturn, now we're at Jupiter. Jupiter currently has 90 known moons, and the Juno spacecraft is orbiting it, probably until, I think, projected that it will head into the atmosphere in about 2025. So if we're doing our little survey right now, we might see Juno. But if we were doing it a little bit in the future, 5 or 10 years from now, Juno would be gone. We probably wouldn't see anything. So Jupiter, even though it is such an impressive planet for so many reasons, it's probably not of such interest to us. Now, onto the asteroid belt. So this is roughly between Jupiter and Mars. It consists of rocky bodies. Some of them are high in metals, some of them are rockier, some of them have got more carbon in them, some of them are icier. If you put them all together, it's said that their mass would be less than our moon, but because of the gravitational pull of Mars and Jupiter, they're never going to coalesce into anything. But this is actually quite a busy place, or quite a busy region of space. We find evidence of at least 5 different separate sort of spacecraft. There's Dawn, which is currently orbiting the planetoid Ceres. We find the Minerva 1 lander, a little blue cylinder that's just circling around. And we find a number of asteroids which have been landed on. One of these is Eros 233, which has the comet near Shoemaker, which soft landed on the surface. It was a solar panelled one as well. But the one that I find most intriguing is the asteroid Ryugu. And this is where Hayabusa 2, the Japanese mission, took samples which were returned to Australia in only like last year or the year before. And in order to get those samples, they sent a whole bunch of stuff to Ryugu. So there's at least 6 objects currently on the surface. In fact, they have to be more than 6. This thing here is has lines of sort of shimmery iridescent stuff on it. So this was used as a marker so that Hayabusa 2 could navigate itself to the correct position on the surface of Ryugu. Then there were 4 rovers, but not rovers like we're thinking of, rovers that jump. So they jump on these little legs, and this is one in the process of jumping. So they jump and they move to a new place, possibly in a different orientation. And this one is kind of, looks like it's sort of more crawling along a bit. Then, of course, we have the location where the sample was gathered from and removed. And I'm sure I'm forgetting a few things, but there's a lot of stuff on this little asteroid and very different to the things we've seen already. Although when you look at them, would you look at those little jumping rovers and understand that that was the mechanism? Or would you think those little legs were meant to fix them on the surface? That's, if you're not seeing them in action, how do you interpret these features? So out of the, not quite out of the asteroid belt. This is an asteroid, but it's more properly defined as a near-Earth asteroid. And just last week, the OSIRIS-REx spacecraft dropped a little capsule containing samples of asteroid Bennu on the surface of Earth in the Utah desert. So this is our most recent encounter with an asteroid. We didn't leave anything behind there, but maybe for a little while, this location, which isn't this, but let's imagine that it is, this little place where that sample collection device blew away the surface and made a little tiny crater, maybe that will stay in existence for a short while as evidence of its interaction with humans. So now finally, I've still got more things to tell you about. So this is in the region of the asteroid belt. It's sort of in a solar orbit that takes it sometimes past Mars, sometimes basically in solar orbit, let's say. So does anyone know what this is? I think I'm hearing some yeses. So this is, of course, the red Tesla sports car that Elon Musk launched in 2018. It was a test. It might not have ever got off Earth, but it did. So it's now in space. So Musk said at the time he tweeted, or he X'd, as we now have to say, he said that he hoped it would be a monument that would last billions of years into the future. And he even said maybe future archaeologists will find it. This is an interesting statement because none of these materials were hardened against radiation or prepared for the space environment. It's full of organics. There's lots of plastics. Even most of the car is made of hydrocarbon material. So it's not prepared for the space environment. And some predictions say that some components may last a few million years, but most of it is going to be gradually corroded away. So Elon Musk's hope of immortality in this bizarre artifact is probably not well founded. But for a while, it's going to be out there. It's being tracked. We know where it is. And in fact, I'm involved with a small project at RMIT in Melbourne, where students are planning a hypothetical mission to go and take a sample of all of the particles that are coming off it because of the harshness of the space environment. And it's a hypothetical mission, but I kind of would really love if they were able to do it one day. So now we're getting closer to the inner solar system, the first of the planets which have solid surfaces that you could actually land on. So we hop across to the red planet, Mars. And this is chockers with stuff, but so different to everything we've seen so far. We have stuff that is still on the surface, stuff that is not moving on the surface. We have 3 objects, rovers, which are crawling across the surface and some which are still. We have the little helicopter Ingenuity, which is I think it's had like tens of successful flights now. So it's rising to, you know, a not very high altitude above the surface. We have a whole bunch of stuff in orbit. We don't even know where most of it is. So the first successful mission to get to Mars was Mariner 9 in 1971. And it could still be in orbit around Mars. It could have crashed. We don't have any evidence to say either way, but it could still actually be in orbit around Mars. So there's a whole lot of questions here. So we see here a lot more solar-powered vehicles. There is no way anyone is going to take nuclear fuel anywhere near Mars. We've got these things with wheels on them. So there were wheels on the Tesla, but floating in space, what purpose do they serve? What would you think those wheels were for? Here these wheels are doing something. So they have a function. This just makes the mystery of the Tesla even more challenging. The relationship between these objects, if you were an archaeologist 100 years from now and you didn't have the documentary evidence, which you might not have, like even now, there's so much missing, what we know about the space history over the last few decades. So what would you make of the relationship between these objects? Who's talking to who, or once talked to who? Are they made by the same people? You could build a story by looking at the technological similarities. And if you were doing a proper survey, you could find the location of the missing missions, the things we just don't know where they are. So this is like a gold mine of culture. And if we were these space archaeologists doing a survey from outside the solar system, we'd have to think we'd be getting close to the beings that have made all of this stuff. Although maybe each of the different types of artifact we've seen belong to a completely different type of being. How are we to tell? We're not really going to be able to tell until we find some evidence of objects where these beings might have been interacting with them or been inside them in some way. All right, the Starman, but I mean, that's a very tricky one, I think, to interpret. So the other thing we see on Mars is the creation of ephemeral tracks created by the few rovers that are still moving. We have lots of images of these. This is a set of tracks taken by the rover Spirit, which is no longer operating. And what's really interesting about these tracks is that a Morse code for JPL, the Jet Propulsion Laboratory, which made the spacecraft, is in them. So as it rolls over the surface, it imprints JPL into the Martian surface. These tracks are great evidence of what those rovers were doing, where they started, where they went. But of course, Mars is not like some of the other planets. It's got a very active weather system. There are winds, there are storms, and we know that these tracks get erased pretty quickly. So any that survive would have an incredibly high archaeological significance because they would be a rare site type, a rare feature in the landscape, and because to future researchers, they tell us something about what happened on that surface. So they're very ephemeral in the Martian environment, but there's one place where they're not so ephemeral, and that's on the surface of the next body we visit. On the surface of the moon, you can still see the tracks from the Apollo 17, 16, and 15 rovers. There's a picture of one of the rovers just there. So this image is taken by the Lunar Reconnaissance Orbiter from a height of about 50 kilometers above the surface of the moon. And that's the landing module. And the two parallel tracks show us very clearly that this is where the rovers drove. But these rovers, you can immediately tell, are very, very different to the ones we've seen on Mars. They have a space for bodies to go. If you didn't already know what those bodies were like, you would know from the footprints that you can see all over the site, from the spaces left for a body to fit, for the instruments that are meant to engage with hands and feet. So this is, and look at its beautiful little mesh antenna. And it's a buggy. It's more like a car. It's more like the Tesla than the rovers on the Martian surface. So this is a very different kind of cultural tradition that we're seeing here, but much older than a lot of the things that we've seen. So this one's Apollo 17, that's 1972. So we're not only going further into the heart of the solar system, we're finding more material and we're finding older stuff, all of which suggests that we are getting close to the place where these things are coming from. But let's stay on the moon for a little bit. These are pictures taken by the Lunar Reconnaissance Orbiter of the 6 Apollo landing sites. And you can see the reason we're able to identify them is because of the shadows that they cast. And to me, these shadows are part of the archaeological site, not just because they help us see the site, but because they're a material feature of how the site interacts with the lunar landscape over the course of the 2 weeks of day and the 2 weeks of night. And interestingly, so when people who believe that humans never went to the moon are asked, is there anyone in the room who thinks humans never went to the moon? I don't think so. This is good. There's always one. So you can say to them, but we can literally photograph those landing sites on the moon. And the argument they make is, well, you cannot verify that that photograph is of that place or came from that spacecraft. How would you do that? You're just saying that. You can't prove that. And in fact, why am I saying this? They kind of have a point. So we have to believe in the science to understand that these pictures were taken where they were taken and accurately depict what they picked. Looking at these 6 comparisons, what we're actually, in the shadows that we can see the landing modules in the middle. In the earlier ones, these are not rovers, these are human foot traverses. So it's only when we see the double lines that we know that it's a rover. But we can see in each one of these, we can see how humans moved around the landscape. These are from the Lunar Reconnaissance Orbiter, but we have video and huge numbers of photographs from on the ground. And right at this moment, there are people proposing to go to the moon to make permanent habitations and to mine the water ice in the lunar poles, to also investigate other sources of interesting minerals that are present in various locations on the moon. So these sites are under threat. Lunar dust is very sticky, highly abrasive. If you stir it up, it's going to start eroding and eating away at these surfaces. We could learn so much by comparing the traces left at Apollo 1 through 12, 14, 15, 16 to see how each generation of Apollo astronauts learnt from their predecessors. This is the hallmark of human culture, and adapted themselves with better equipment, more knowledge, and different objectives for each mission. And no one has ever done that work. Like, there's about 3 archaeologists who specialize in the moon, and we're so busy trying to persuade people that it matters that we haven't done this ourselves. No one has ever done this super simple thing of comparing the footprints and the rover tracks at these sites to see what they tell us about how successfully or not successfully the astronauts adapted to the lunar environment. And it seems to me that's a fairly critical question for the missions that are proposing to go to the moon and stay there for longer periods. And yet, it hasn't been done. So I think this alone means we need to preserve these sites, because the science they can provide for us has barely even begun. So I think I still have a little bit of the moon to talk about. So obviously we have all of these objects. We have the rovers, the landing modules, we have the experimental packages, we have the rubbish that was thrown away. We have the television cameras which recorded each of the missions. And in fact, I think those television cameras are possibly even the most significant artifacts at those sites, because they were what enabled the human audience around the world to actually watch people walking on the moon. I'm just old enough to remember it. But it's more than this as well. So things like the footprints and the rover tracks and the trenches dug to take samples and the core pits and a whole bunch of stuff are what we call, on Earth, they're called trace fossils. They're not the thing itself, but they're a trace left in the environment of the movement or the activity of the thing. And these are hugely interesting in studying, the entire world of living things. The picture I've shown you here is a set of footprints, possibly made by Australopithecus afarensis, walking across a soft volcanic ash landscape. And these footprints and those of many animals and other hominins were preserved. This is at the site of Laetoli in Tanzania. These footprints are dated to 3.7 million years ago. And on the surface of the moon, we have much more ephemeral, to a degree, footprints made, millions of years later, but from an archaeological perspective, demonstrating a cultural trajectory, a movement off Earth and into space, movement from a body which is quite different to ours, but ancestral to ours, to a body which can only survive when it's encased in its white sarcophagus of a spacesuit. So these are really interesting, but from our archaeological perspective, we're seeing these trace fossils, but we've not yet seen the people who made them. Oh, and yes, there's more. So I mentioned that there's all these plans to go back to the moon. I'm sure you have been reading constantly in the news about these various missions. Just earlier in the year, we had the Indian Chandrayaan-3 mission, which put in an orbiter, a lander and a rover on the surface of the moon. The failed Russian one, Artemis 2, the US one, is launching imminently. But we've also had some interesting crashes onto the moon. So the thing about crashing onto the moon is that you make a crater and the crater stays there. And thinking about this image is actually from, I think it's a couple of years ago now, that an amateur astronomer saw that an artificial object looked like it was going to hit the surface of the moon. He surmised that it might have been a SpaceX rocket that had delivered a spacecraft to the L3 Lagrange point, I think. And it was spent, and it was tumbling in a chaotic orbit, was going to fall onto the surface of the moon. It actually turned out to be a Chinese upper stage from another mission, But it aroused quite a bit of interest because it was being observed as it was falling, and because later the Lunar Reconnaissance Orbiter actually found the place where it landed. So one of the concerns, as there's an increase in the amount of proposals to go back to the moon, is that we're going to see more of this. There's going to be more things in orbit, there's going to be more rocket bodies, there's going to be more crashes on the surface. And I think of this as there's a phase in the early history of the solar system called the late heavy bombardment, which we actually know about principally from the returned Apollo rock samples. But these are all, you know, meteorites, bits of asteroid, I don't know, natural stuff you might call it. What we're starting to see now is an increase in, I might call them cultural meteorites, objects that humans have made, crashing and leaving a distinct archaeological record, new kinds of trace fossils. And I don't see any reason to necessarily separate these two processes. Obviously, one is on a much smaller scale, but it's also part of what people are now calling the Anthropocene, the new geological era where we can detect the results of human activity in a permanent way through the geological strata. So the Anthropocene is happening in space, and I'm calling this the new bombardment. At some point, it will cease to be new as well, because it's kind of on the leading edge of this phase of increased activity around the moon that will leave many, many more of these craters. So if you know, you were thinking of space as a fairly static place where nothing much happened within the human timescale, this stuff shows us that we're now making that timescale meaningful for these celestial objects. So from the moon, we can't see this, but as we get closer, well, in fact, we still wouldn't see this, because just like the other ones, this is not to scale, although each of those dots does represent a real spacecraft, but they'd never fit in one picture if we actually had them to scale. But this is a general representation of what space junk in Earth orbit looked like a few years ago, before the massive increase in the launch of mega constellations like Starlink. So here we have low Earth orbit. Here we have geostationary orbit, which is where most telecommunication satellites used to be, and some navigation satellites currently are. So this is kind of what it generally looks like. So this is, given the sparse distribution of objects we've seen in every other place in the solar system, it would seem pretty clear that this is like the home planet. This is where it's all coming from. If we had the right instruments, we could scan all of those objects to find out which one was the most weathered, which one's surface was in the poorest condition, indicating it had been out there for the longest. Of course, that's a correlation that has many factors that could make it not direct, but for the purposes of this, we'll leave them out. What we would find, fingers crossed, is this satellite. This is Vanguard 1. Launched in 1958 and currently the oldest human object in space, not even just Earth orbit, but in space. And it's about this big. It's quite little. It was a polished aluminium surface. It had solar cells. In fact, it was the first successful use of solar panels for power in space. So it has a direct lineage to those spacecraft we've seen in other parts of the solar system using solar energy. It has these 6 sticking out antennas, and what we will find is that its surface is no longer silver in any way. It's extremely pitted and tarnished by reason of exposure to the space environment. We can actually use spectroscopy instruments to get some of this data from the surface of Earth. It's just that not many people are doing it. So this to me is quite an extraordinary object. That now it's space junk, but I think its cultural value is something else altogether. So there's a lot of space junk up there in Earth orbit. People are very concerned about it, quite rightly. There's a lot of proposals for how to actively get rid of the old stuff there's a lot of proposals for how to launch new missions to minimize the amount of debris creation. But the situation, if we were to visit Earth, let's say, I don't know, hypothetically, let's say 50 years from now, maybe we might find something like this. Instead of a whole lot of junk, but perfectly possible to safely launch or to enter through that junk, you might find the situation that's known as Kessler syndrome. So this comes from a 1978 study done by Donald Kessler and his colleague Burton Court-Pillay, who I always like to mention because everybody forgets about him, they leave him out, but he was a co-author on this paper. They were actually interested if the amount of space debris in Earth orbit would ever form a planetary ring, like naturally coalesce into a ring system. Their conclusion was that there wasn't enough mass in what was up there for that to happen, although that situation is changing, so I don't know, maybe they would get different results today. But the thing everyone's fixed on in their paper is that they predicted that certain regions of space could become unusable because of a cascade of collisions between space junk. So in low Earth orbit, objects move at approximately 7 kilometers per second. So collision at those speeds is generally not great. What the Kessler syndrome describes is that if a collision occurs, it creates new pieces of space junk. They go on to collide with other pieces of space junk, which create new pieces of space junk in their turn. And you could get to a situation where this was a self-replicating, continual cascade of collisions to the point where it would no longer be safe to leave Earth orbit. And if any of you have seen the wonderful film WALL-E, you might remember the rocket bursting through the ring, the sphere of space junk around Earth. Anyone remember that? It's quite a stunning scene. And a little Sputnik 1 gets tangled up in the rocket's external bits, which is beautiful, except Sputnik 1 re-entered a long time ago. It's not up there anymore. So that's Kessler syndrome. That's what it potentially could look like. There are differing opinions about when it might happen. Some people say it's theoretical, we're not anywhere near that situation. Other people say 20 years and we're there. Every time there's an anti-satellite test from the surface of Earth, the risk heightens, and the more of these mega constellations that are orbited, the closer we get to this point as well. A number of science fiction writers have speculated about what it would mean to be shut into planet Earth, unable to leave because any spacecraft would be immediately bombarded by these high-speed fragments and be smashed up in its turn. Of course, the other side to that would be, from our perspective, if nobody can leave the surface, similarly, it would be extremely difficult to visit. So we'd have cut ourselves off from those aliens we've been longing so much to find all these years. A situation I think Douglas Adams would have turned into a very witty and interesting part of his tale. So this isn't what we've got right now. It's a future that could be. It's a future that could well be if more steps are not taken in the present to ensure that it doesn't happen. But let's leave this gloomy speculation and hop across to my favourite planet, Venus. This is extremely interesting because throughout the 60s, 70s, 80s, and even into the 90s, the Russians were sending missions to Venus to land on the surface. And I think there's at least 26 locations where there's human material. And a lot of the Venera landing craft looked like this. What does that remind you of? Come on, you know what? Well, I know what it reminds me of. Anyone want to venture their opinion? I think they look like Daleks. Don't you reckon? Okay, nobody reckons. Maybe it's only me. Anyway, so you have these. There's how many of those? 7 or 8 of these standing on the surface of Venus. People say they won't have survived. On the surface of Venus, it's 400 degrees Celsius. The atmospheric, it's 90 Earth atmosphere's worth of pressure. People also point out that there's a band of sulfuric acid rain in the sky of Venus, in the lower cloud decks. However, I'm not so sure that they haven't survived. First of all, they were built to withstand those conditions. What's interesting about the Russian Venus space program is that it shows a really interesting evolution of technology. When they first started launching spacecraft to Venus, the US were also sending, I think, at least one Mariner, went past Venus and brought back information. There wasn't a lot of concrete information about what surface conditions were like. So the first spacecraft were crushed as they went down into that incredibly dense atmosphere. So each successive one was built to withstand the environment based on the knowledge of the failed one before, until they got to this point, where they had a titanium sphere. The later Veneras broadcast data for at least an hour and a half, so they were operating. They had not been crushed, they had not melted, they didn't work after that. So my theory is that they're still standing on the surface. And there's a lot of renewed interest in Venus now. There has been recent suggestions that in the upper cloud decks, there could maybe be floating microbial life. It's quite contentious. I don't think it's been demonstrated securely enough for people's opinions, but that possibility is there. Rocket Lab has sent or is about to send a mission to Venus. There's quite a few people in Team Venus in Australia. Isn't that right, Jonty? You're on Team Venus, aren't you?
We've also collaborated with some of the missions about that.
Ah, fantastic. Brilliant. So there you go. Australia is Team Venus. So people are thinking about going back to Venus, but it does have this really interesting archaeological record. Fortunately, probably no one wants to mine Venus. So the risks to these sites aren't the same as they are on the moon. And I will fight anyone who tries to destroy one of these beautiful Venera spacecraft. I think they're really special. Okay, we're nearly at the end of our journey through the solar system. So the last planet on this trip is Mercury. Mercury is like the moon. It's another airless world, which means that its surface is covered in craters, showing all of the sort of geological eras of the solar system. Like the moon, it has permanently shadowed regions at its north and south pole, which have trapped volatiles, possibly water ice, but certainly a whole bunch of things that you kind of wouldn't have expected to find there until we got some, new science done, I guess. Mercury has one archaeological site on it. And this is a crater where the Messenger spacecraft crashed when it ran out of fuel in 2017, I think it was. That crater would look very different to the outside eye than all of the craters that are much, much older and made by quite different sorts of object. So if we were in a position to look at it from the outside, it would probably be quite obvious it was created by an unnatural object. But no one can see it, of course, because we don't currently have any spacecraft at Mercury, but we soon will have. So Bepi Colombo, I think, is due to go into orbit around Mercury in 2025. And it too will crash on the surface eventually, but it may actually also give us a picture. It may not, but it may, of the Messenger crash location. So Mercury is kind of like the moon in its geological history, but its archaeological history is very, very different to what we've seen on the moon. So we're now going to leap the closest we can get, the sun. And this is where the Parker Solar Probe is currently heading. To get to the sun, you'd think it would be a simple thing, just go straight ahead that way. But it's had to loop around Venus and I think it might be going to loop around Mercury as well. But getting close to the sun is a really difficult thing to do. So you can see here, it's extremely heavily shielded because of the heat that's going to be flung at it. It's already sending back really interesting results, but in fact, I think this is 2025, which is going to be an interesting year. I think that's also the year where the Parker Solar Probe will get closest to the sun. And I'm not sure what end-of-life plans are for the Parker Solar Probe. Probably they're just going to keep sending it towards the sun until it burns up, so we can get every scrap of data up until the last minute. There are a few other spacecraft which are orbiting the sun from a respectable distance, nothing like as close as the Parker Solar Probe. So this one we won't have to study in the future, but while we do have it, I think it's quite an extraordinary mission. So this is the one inhabited solar system we have the opportunity to study. So what have we learnt about it by taking this tour from the outside into the centre? Well, the sorts of things I have learnt about it by thinking about this. First of all, we can say that the entire solar system is what we call a cultural landscape. We can no longer really separate the natural parts from the cultural parts, the human manufactured parts. They're now sort of working together. Everything human made is part of the environment that it's in. So particularly in cultural heritage terms, we call this a cultural landscape because the values it has lie in that interaction. So if you were to simply remove all of that stuff, you would have lost your ability to learn things. What we can find out from these places depends on them being still in the landscape where they were intended or maybe not intended to go, but where they ended up. So this solar system, this inhabited solar system, is a cultural landscape. Another observation that comes to me thinking about this, so, you know, you'll hear much talk of the spacefaring nations, and Australia has kind of always been part of that circle, but we're definitely aspiring to become more spacefaring than we used to be. But if you think about it, how can we say we're spacefaring when we're basically confined to the surface of Earth? Space belongs to the robots. We do have a tiny population of people in low Earth orbit, about 400 kilometres above the surface of Earth. Does that count as spacefaring? They've hardly left. 400 kilometres is the distance between Toowoomba and what's 400 kilometres away?
Harvey Bay, Lady Alley.
Okay, Harvey Bay. We're going to say the International Space Station is as far away from us as Harvey Bay is from Toowoomba. So there you go. So I don't know. I don't think that counts as spacefaring. It's a perpetual topic of debate in the space world. Robots can basically do everything that we need to do. Do we need to send humans there at all? When we look at the record of the entire solar system, what we see is humans on Earth and robots in space. So I don't know, we can make of that what we will. I mentioned the Anthropocene before. So what we see by taking that solar system perspective is materials from Earth gradually being sent off Earth and being distributed throughout the solar system. Very, very low density, the further away we get, much higher the closer we are. But we're actually starting to take apart our planet. And if we move mining off Earth, we're going to be starting to dismantle other planets and moons. And this strikes me as a really interesting thing because many science fiction writers have speculated about terraforming other planets, turning Mars into an Earth-like environment so people could go and live there, or creating little bubbles of habitable environment in places outside Earth. There's been a lot of science done around this too. But what we're doing at the moment is taking Earth and soon the moon apart. We're kind of doing the opposite of terraforming. So I think that's kind of interesting. And of course, the other thing we see across the solar system is representatives of different kinds of political ideologies. A lot of this stuff is from the Cold War. So that was obviously capitalism versus communism. What we're seeing now is a dominance of capitalism. I mean, they did win the Cold War, if such a thing can be said to have happened, with a growing ecological movement, which says we should be interacting with space in a different way. So that's going to have its own material record. And these competing ideologies will be visible in the spacecraft we see in the future. Now, I'm nearly at the end, but in fact there is one, I'm going to do it briefly. One more thing I want to do. So we've looked at the whole solar system, but there's only one celestial body in the solar system that's on the brink of collapse, and that is our own Earth. And this is, I don't know, an interesting sort of paradox, I guess, when you think about a very influential idea that was made by a Russian scientist, Nikolai Kardashev, in 1964. It's quite an old idea now, but it's been widely influential, still talked about. So Kardashev made a scale about how much energy different types of civilization would use. And I'm saying civilization because that's a terminology. It's not a word I would normally use in my own archaeological discussion, but this is what they said. So a type 1 civilization was capable of using the energy of an entire planet. So we're not even there yet. Type 2 would harness the energy of an entire solar system. Type 3 would harness the energy of an entire galaxy. So those were the 3 Kardashev types, and people then developed a few more. So type 4, the energy of the whole universe. Type 5, moving into the multiverse. And type 6, this is something that, you know, we can barely speculate about or conceive of. So this is the Kardashev scale. I'm going to propose a different kind of scale. I'm going to propose what I'm calling the Gorman Index of Solar System Sustainability. This is a way of measuring in any given solar system, testing it hypothetically on ours because it's the only one we've got enough information on at the moment, but we might get more information on other solar systems as we have the James Webb and various other space telescopes gathering this data. So this is an index which calculates how sustainable an inhabited solar system is. So you start with the number of planets in a solar system, the number of those which are uninhabitable or have been so irreversibly harmed that they're not in the future habitable. You factor in the age of the sun that those stars are orbiting, those planets are orbiting, because the age of the sun is the time of opportunity in which to destroy or not destroy a planet. And then you do more sophisticated maths than the one I've shown you there. And you calculate for any solar system in a scale between 0 to 1, how close is it to being sustainable at 0 or 1 to being completely ruined. So we can test this on what we're doing right here now in our solar system. Soon we will actually have enough information to have a go to see how it might apply to other ones. And I think this is an interesting way to reverse the Kardashev scale and to stop focusing so much on Earth and start thinking in a solar system context that can be informed by those archaeological traces, which we have briefly surveyed, and which we might have to consider more and more as we go into the future. And this is my final thought to leave you with, a quote from Gaston Bachelard's 1958, The Poetics of Space, a book in which he didn't once mention outer space or any spacecraft, but in a way the entire book is about how humans relate to space. This quote is about shells, but I think we have made many kinds of shells. Planets and moons are the shells where we can hide and live safely. Spacecraft are shells that hide human equipment and instruments, but also aspirations and hopes. Some of them are dead, some of them have never worked, some of them are empty as well. So Bachelard says, besides for one living shell, how many dead ones there are? For one inhabited shell, how many are empty? That is the end. Thank you for your patience in listening.
Fabulous. Thank you very, very much. I'll get Des to bring the lights up, and while you have a drink and just refresh yourself, I'll get the wonderful Caitlin and Terry to come in with the microphones and invite any questions that people might have for Alice.
G'day. My first observation is in terms of Gaston Bachelard, who presumably is a Frenchman. The fundamental problem you've got is how you define destroyed. Because the mass, you can always find something to do with it, with mass. Elements are always there. You can always do something with them if you've got a source of energy. So there's a question there which really, I can liken it to the motor car industry. I restore old Citroens and I can drag a piece of rust out of the paddock and I can turn it back into a car that I can then sell for a stupid amount of money. So is there any move to refine the definition of a destroyed planet in terms of what can be done with it by ingenuity?
Well, indeed, this is one of the key definitional problems of making this index, because once you start to dig into what it is that makes something ruined. So I wouldn't necessarily say destroyed. There's a lot of literature on how you would blow up a planet and cause it to cease to exist. But then, as you point out, you can still use that material for stuff. So where to draw those lines is going to be a key issue in making that index work. The interesting part of it, though, I think, is in order to do that, it then sharpens up what you think not doing that is. So even if one doesn't arrive at a definitive way to describe a ruined planet, the process of trying to define it will actually be just as interesting. And I'm as interested in that as I am in the other stuff. I mean, there are some things that are probably easy enough to do. So a large scale nuclear war on Earth would render it uninhabitable by, you know, most living things. Not all probably, but most. So you could say, well, probably no one is going to dispute that that is ruined to a degree. But there's a couple of other things. You say, well, okay, what is a good working planet? What is a planet we can define that's working well in the circumstances of having a sort of a global, well, I'll have to use that word civilization, which I don't like, but what counts as working well? Because to define one, you'll have to define the other. And then there's also habitability indexes or indices, which are used for exoplanets. So I see this as something different to a habitability index, but obviously they're related as well. So you're right. Those definitions are going to be absolutely key to making this work. But you know, it's a thought experiment at one level, I think, and attempting to make it work. For me, will lead to enough insights to make it worthwhile.
So just pondering your thoughts on the moon and reflecting on, you know, how could those sites be protected? On Earth, we have things like World Heritage listings, etc. Has there been any discussion around how might we protect those sites in some way?
Fortunately, yes. So just in recent times, there's been first of all, well, the easy way out, a World Heritage listing we can't do because, first of all, World Heritage listings have to be proposed by a nation and are, you know, very strongly tied up with nationalism, which is sort of at variance with the ethos of the Outer Space Treaty. And the second thing is they generally have to be within national borders. So it doesn't mean the concepts of World Heritage can't be applied. So one of the key concepts is outstanding universal significance. And it would be easy to argue that Apollo 11, for example, might meet the criterion of outstanding universal significance. So those criteria can be used without there actually being a legally binding sort of World Heritage list thing. What's being thought of at the moment, so there's been a number of, there's a document called the Hague Building Blocks, which is a result of a few years of work by a group convening around The Hague So they have in there some principles saying that the natural and cultural heritage of the moon needs to be taken into consideration. They have suggested a sort of an international body that could administer things like making a list of heritage sites. So that's pretty positive. I've been working with the Global Expert Group for Sustainable Lunar Activities. And I have to say, I'm pretty generally like the only person with a heritage background in a lot of these meetings. So I try really hard to make sure that this stuff gets in. But we've put some quite detailed principles together for our report that we took to the UN this year. And I do have a couple of colleagues working on the moon who are looking at the various factors which can affect the sites, the geological setting, selenological setting, and how that's going to affect their survival. And we're talking about what criteria we would use to make a good heritage list for the moon. What most space organisations seem to think is that they can get an internationally agreed list. That's going to be really helpful. And that's something we do, you know, in the heritage world, we do that every day. In the space world, they're not so used to doing that. But we're working with various groups to hopefully make that happen. So I suppose it's looking quite positive. But what we all think is that the minute people get on the surface of Earth, because if you could sell a piece of an Apollo site that came from the moon, the black market on that stuff is going to be out of control. So there's a lot of incentive to, and yeah, it would be surprising if that didn't happen on the moon. So yeah, we need a lot of these sort of principles in place before people get to, like that, Jonty and I were just talking about the terrible event of the tree at Hadrian's Wall being cut down just last week, I think. Yeah. So people will do this stuff and they'll do it on the moon. They do it everywhere.
You find the pieces in the British Museum. That's where it normally goes, isn't it? If an archaeological site has been pillaged,
Oh,
it's
right,
in a
yes.
museum in the UK.
I'm sad to say, but yes.
Yeah, thank you very much for that talk. It was very, very interesting. I just wondered if you had a view about all of the space material that's deliberately dumped in the southern Pacific Ocean.
I do have a view. As a disposal plan, I actually think it's one of the better ones. So that part of the Pacific Ocean, often called Point Nemo, the stuff goes down 4 kilometres. There's a couple of sort of oceans called the South Pacific Gyre. There's not strong currents there. There's few commercial shipping lanes, very low biotic mass, extremely low. So we're not talking, you know, incredibly rich, diverse marine environments teeming with life. It's there, of course, but it's not like ecologically, it's not biodiverse, it's not endangered either. So generally, I mean, there's a lot of toxic rocket fuels, but they're not generally used in the spacecraft that end up down there. And the fuel is usually expended by the time they get there as well. There is potential for such things to become artificial reefs. And in shallow waters, that has been seen, you know, around historic shipwrecks, World War II, planes, submarines, ships. I think even a couple of shallow water re-entered spacecraft have been shown to foster, you know, quite vibrant communities. But at Point Nemo, nothing much is happening. So, I mean, the rules are changing. What people are expecting is changing. But if you were going to have an environmental impact, that's possibly one of the best places you could actually do it. So I would think it preferable to send things down there in that deep water rather than shallow waters, which are a much bigger concern. And shallow waters obviously tend to be coastal, so they're quite close to terrestrial environments as well, and all of that stuff. So, okay, I guess that means I like Point Nemo.
All right, going back to the moon. Some years ago, NASA announced that the lunar rovers were available for salvage. They basically renounce their sovereignty over those artifacts. How is that dealt with your list of artifacts to be protected?
What's happened now is two of the rovers, I forget from which missions, there were three which had those rovers. The two that were made by Boeing are now listed in the state of Washington's historic landmarks register, which they can do. So you can do that to an object, you just can't do it to a site because that could be a national claim, but to an object, and then this has happened for a number of US things, they can be put on a state register. So two of them are kind of now protected. I mean, legally, if somebody did decide to salvage them or, you know, bought the rights to salvage them, well, they wouldn't sell them now. They can't sell the rights to salvage them now because they're protected. But if somebody, it would be interesting to see how that played out in the courts. And I don't know the status of the third one, but this also raises a really interesting case. So Richard Garriott, who is the son of Owen Garriott, who was a Skylab astronaut, and I think he did another mission as well. So his son, who was one of the few commercial space tourists, he made huge buckets of money making video games. And he used this money to go to the International Space Station. And he used this money to buy the Russian Lunar Cod 2 rover, which Russia was always being strapped for cash, quite happy to sell to him. And he did that explicitly to test the limits of claiming territory on the moon. So he now owns it. Russia doesn't own it. So in treaty terms, that's kind of interesting. If someone tries to move it or salvage it or do something with it, he can presumably take that up legally somehow. But I think what he's hoping to do is at some point to convert that into something he can make a territorial claim out of. So I suppose he's just kind of, he's being a bit wicked. He's playing with the ideas. And that's going to be an interesting one if anybody ever gets close to it or has another idea.
While people think up a question, one thing worth noting with that is that there is somebody who has made quite a lot of money selling 1 acre plots on the moon. And it's probably worth noting that if you were interested in buying a 1 acre plot on the moon from this person, those are considered to be utterly unenforceable and something of a scam, I think is the best way to describe it. But technically,
I mean, if you want a little certificate and that's the thing that's useful to you, yeah,
yes.
that's...
But that's another one that would be interesting to see if that were tested. If somebody lands there and somebody says, I've got a prior claim because I purchased this, what is the legality behind that? The space treaty is 50 years old, 60 years old, and is not really tested in that thing because it wasn't written with those things in mind. So how does that get worked around?
I can tell you because one of Australia's leading experts in space law, Professor Stephen Freeland, who's also the chair of the working group for lunar resource management of the legal and technical subcommittee of the United Nations Committee on the Peace and Use of Outer Space. He's like Australia's representative at all of these high-level forums. So he says the treaty is very clear on that stuff, fortunately. So the words in the treaty are, you know, you cannot make a claim by means of use, something or other, and by any other means. So according to Stephen, that by any other means means that any other means cannot be, I actually have sold this to someone who paid for it and here's the legal document that says they own it. So a lot of people, someone bought the moon once, no, the sun, they bought the sun. Do you remember that? Yeah. They said, we own the sun now. So yeah, there's quite a few examples of people thinking we found the loophole in the treaties, but according to Stephen, the loophole was closed even in 1957 by any other means, which is interesting to know.
So to make that clear, according to that treaty, if countries and commercial entities abide by it, there is no possibility at the moment for anybody to own anything off the Earth, which is a challenge when you come to asteroid mining. Because how do you protect your site? How do you claim your site? So there's all these kind of things come into this discussion as problems we haven't yet solved. And one of the issues we're running into, which we talk about a lot with mega constellations, is that the legislation is lagging behind the use. And so you hear a lot about astronomers saying these are bad. And it's not just astronomers complaining for the sake of it. It's a bit of a Wild West situation. And a lot of these things, people will try things to test whether the legislation holds and whether people will enforce it. And there are concerns that American companies, for example, will intend to set up mining operations on the moon and claim that site as their own when legally they can't. But the US government is in favour of commercial exploitation. So will they really enforce this? So you've got all these really interesting interplays that I think they're problems we haven't solved yet. And hopefully
I think
we will do.
you're right too. I mean, the interesting thing, you're right, because they'll come to a head at some point, but we don't have a court system in place to deal with them. And also, we have the Lunar Reconnaissance Orbiter. We'll have a few more things in orbit. We can't see what people are doing necessarily either, depending on the scale of what they're doing. So verify ground truthing, it's going to be an interesting thing too, yeah.
That's going to be an interesting one. And just for the people online there who possibly didn't hear that comment, there was a comment there about the specific wording being too vague and possibly opening up the potential for challenges with big money around exactly what any other means actually does not cover, and allowing people to try and claim ownership and then fight it through the courts.
Keep going.
That's okay. I was just wondering if we had an online question.
No, there's no online questions, but I have a comment, observation. People may not have heard you on the radio this morning. I thought you made an interesting point about the Velcro on the space station that you may like to relay again for the people in the audience. But in thinking about the stuff that has gone outside the Earth's atmosphere, it's a very hostile environment. So things like the American flag on the moon's bright white now, and so that therefore people observing these artifacts in the future may not be able to distinguish nationalities or other aspects, or they look at this plain white flag and think, I wonder which country that was, or
Who did
whatever.
they surrender to? Oh no.
Yeah. So, but they, however, videographic or other printed or other material that perhaps would explain that. So I'm wondering if you're interested in commenting on the significance then, not so much of the artifacts in space, but of the significance of the material that describes what they are and how important that may be to distant future archaeologists to understand what the cultural landscape was.
Thank you for bringing that stuff up, Des. So I don't know, maybe I should start with Velcro for those who weren't listening to the radio this morning. So one of my other projects is the International Space Station Archaeological Project, where me and my colleagues from the US are using the very extensive record of images and photographs over the last 20 years to look at how humans use objects on the space station. So the idea is that this is kind of what all archaeologists do, I guess. So there's what's supposed to happen, and then there's what actually does happen. And that's kind of what we're interested in. So one of the things that has captured my imagination from the beginning, well, I started with cable ties, but I'm not going to go into detail on the cable ties. Then I moved on to Ziploc bags. I'm still very much in my Ziploc bag headspace, but Velcro is becoming an increasingly bigger concern. So what these things, including Velcro, do on the International Space Station is replicate a form of gravity that is in little patches, that is discontinuous and distributed in different locations throughout the different modules. So basically, you know, you're in microgravity on the International Space Station. If you let go of something, it floats. And it turns out the human eye isn't well adapted to sort of looking in the middle distance. So if you let go of something, you can look away for a second, look back, it's gone. You can't see it. You don't know where it is. There are 6,000 lost objects on the International Space Station. So to stop losing things, most objects have a little Velcro patch on them. And there's Velcro patches all over the space station, everywhere. So wherever you go, you can stick things down and they don't move. So that's gravity. They're replicating gravity using Velcro, which I think is fascinating. Oh, what was the other bit?
About the actual ambiguity of the outside of the Earth's artifacts, and then perhaps the geographic or other written records, the significance of that, then explain to future archaeologists what the cultural landscape was at all.
So I think you're talking about the relationship between the documentary record and the objects. So there's, a question I often get. People will sometimes say, why is what you're doing archaeology and not just history? It's a good question. So historians generally focus on the documentary record, which isn't just written documents, it's plans, photographs, images, drawings, things of all kinds. And we focus on the actual objects. And if we're looking at the deep past, obviously, we often don't have any kind of documentation, particularly if we're looking at people who don't use writing as we would understand it as their primary form of communication. But the closer you move into the sort of historic period, the more written down stuff you have. So people often say, well, why do you need to do the archaeology? You can just use all of this information. Hell, you can just go and ask the person who was there. What did they do? And we can do all of this stuff, which is an incredible resource. We have access to all of this information, which, my archaeological colleagues who work on the deeper past don't have access to. But these things don't tell the whole story. So if you think about the first thing is each document and each person's recollections come from their perspective at that moment in time. We're looking at a much broader picture. We're looking at changes we can document statistically over time, for example. We're looking at what is the meaning of this thing in here in relation to this thing here, whereas the person writing or recounting is focused on the thing that's relevant in that moment. So you can tell a huge amount by reading these documents, but it doesn't mean they have the whole story. And then there's the background to human culture, stuff you don't even think about, because that's how your world works. It's your everyday life. And if someone asked you, I do this with my students, I try to make them extract themselves from their situation to see the things you don't normally notice because they're just routine things that you do. So that goes for space as well. So we use all of that stuff, but it's not enough sometimes to answer the questions that we have. And the other thing that happens, and this is, increasingly people are getting rid of archives because it costs money to store and curate them. And sometimes things just, so one day I was in my office at Flinders University and I saw a news story, I heard on the radio, I can't even remember anymore. Oh God, I've got another story like that too. The one I was thinking of was I heard that AWA, Australian Wireless Association, which used to be AIWA, which was a manufacturer of components in Australia's early space industry. I heard they'd been taken over by another company and they were shutting down their offices in wherever it was. The first thing came into my head was, oh my God, where are their records? Where are their archives? What's going to happen? So I spent like half a day ringing people trying to find out what was happening and nobody could tell me, no one had even thought about it. And I thought I could have kept going. Like if I just kept going, but I had my normal work to do. I could probably have got to the bottom of it. They're probably gone now. That's gone. And you would be amazed at how much is gone. And for some things, we don't have any of that stuff. We only have the object. So that archaeological perspective. Okay, I'm going to tell you another story, just 'cause it's an amazing story. So one day I was talking on the radio about space junk. I went back to my little office and the phone rang. And a bloke answered the phone and said, I just heard you talking about this. I was about to put in the recycling bin all of my paperwork to do with the launch of the satellite Australis Oscar 5. And then I heard you and I thought, oh, maybe she'd like it. And I nearly exploded because Australis Oscar 5 was a satellite made by a bunch of students at Melbourne University that nearly got launched into space as Australia's first satellite before our official first satellite, ReSat 1, in 1967. And it's up there, it's a piece of space junk. It's the oldest Australian object in space. And I'd been looking into it, but I didn't know that those folks were still around. And I just think that thing, he could have heard me on the radio. I mightn't have been in my office. He might have rung and thought, oh, well, she's not there, whatever. I happened to be there. I answered the phone. Oh my God. These things are an incredible part of Australian space history. Don't throw them away. It's like, oh yeah, it's all right. And then we met up and then this led to a reunion of all of the Australis Oscar 5 people. So the satellite celebrated its 50th anniversary a couple of years back. Actually, I suppose it was just pre-COVID. And we're trying to get it heritage listed now. But just how close we were to losing all of those records just makes my spine chilly. Yeah.
Another question at the back.
Having found that stuff, have you managed to find a program or create a program to teach students how to read it, particularly technical and engineering stuff?
I have not created such a program because, unfortunately, I have to teach regular archaeology to students. So I don't have the capacity to do that just yet. But for aspiring space archaeologists, this is one of the areas of expertise that has to be acquired. You have to learn about astrodynamics. You have to learn about spacecraft materials. You have to learn how to interpret those archival documents. I mean, we do a lot of that work with other kinds of historical industries, but space requires some of that specialist knowledge. So this might be partially why I haven't had as many PhD students as I'd like, because you have to kind of, I don't know, enjoy that stuff to a degree to want to get into it. But just as an aside, it's now, since my day, because people don't write in cursive handwriting anymore, or write as much as they used to, students can no longer easily read old archival documents. Like, it's hard enough at the best of times, but they can't. Cursive writing is a mystery to young people today who just haven't been taught it or had to use it, so we are losing skills in that thing at a high rate.
All right, can you go back to your slide of the rovers on Mars, please?
There we go.
All right, now you look at all those vehicles, and when you describe them, you said they've all got different morphology, effectively, to use a biological term. And Perseverance is nuclear powered. But there's one thing that you'll find common to every single one of those when you really look at them, and that is that they've all got the same type of fasteners in them. All the metal is in a same range of thicknesses and the same compositions, because they're all made using AN or NAS fasteners. Now, when you go and look at the Venera and Lunicod, you'll find that they don't have AN fasteners. AN fasteners are chromium molybdenum. The Russians don't have molybdenum, so they use they use a slightly different metal for their fasteners, which doesn't have the same crack resistance. Now, I've got quite a bit of experience working on both US-built aircraft and Soviet-built aircraft. So this is where I was asking the question of whether you have a course for technical knowledge, particularly reverse engineering. But that's how you tell that all those vehicles were built by the same people, because they've all got the same fasteners and they're all put in at the multiples of the same pitch.
Well, that's a fantastic example of different national technological traditions. And it's an interesting thing, because people often assume that space objects or space vehicles are like they're made to incredibly high standards, and they're the most perfect and well-suited thing they could be for the task they have to carry out. And then other people say, you know, every part of this spacecraft was built by accepting the lowest bid on doing that part of it. But there are many, many different ways to achieve the same rough end result, equifinality, we can call it. So you can get to the sort of same place with a lot of different designs, materials, technologies, and a lot of those are kind of centered around communities. Who teaches who learns what materials are available, what manufacturers are available. So you do get the development of sort of unique national or regional or even company technologies, which we can technically see in all of these things. And I love that example. And I love fasteners in general, actually, as you can probably tell.
Awesome. We've got another question down here.
Wondering, with the we did a little bit about the moon and the outer space treaty. Is there anything in place for satellites or the satellite system to potentially stop me walking out next month and seeing a Telstra logo in the sky that is a little group of satellites that have been put up there?
Yeah, there's been a few proposals to do things like that. And as I understand it, technically, it's not against any of the treaties to do that. I mean, it's not against any of the treaties to have light pollution, is it? So if you want to arrange that in a Telstra logo, then apart from, you know, a sort of general understanding that people think it's tacky and not a really good use of the sky, yeah, there isn't anything to prevent that. And there have been a few, just trying to think, there was, people have said, oh, you know, McDonald's arches on the moon, stuff like that. And there have been serious proposals of people who are saying, well, we're going to make this logo and shine it into different places. So yeah, as far as I understand it, there's nothing to stop that sort of thing being done.
And this is a growing area of concern. We've got a PhD student here at UniSQ who's actually based over in America. She's working remotely, who's very interested in cultural astronomy and very concerned about light pollution and stuff like that. And she's very engaged with the International Astronomical Union, which is a big professional body that astronomers have, in trying to help shape policy around the world, try and get people's attention. And there's a number of things about light pollution from satellites that are distinct from the light pollution we get from streetlights. Because with streetlights, you can get away from them. You can drive into the desert. And so around the globe, you've got many cultures, including the traditional owners here in Australia, that have a very deep spiritual connection with the night sky, that it's incredibly important to their culture, to their education, to their heritage. And they are to some degree protected from terrestrial light pollution by the fact that you can move around. It's not ideal, but you can get away with it. And lights built in America don't impact us here in Australia. Lights built in Russia don't impact us here. But spacecraft launched by a given country create light pollution all around the world because they're in orbit around the Earth. And they are being launched without the discussion or the consent of all these different cultural communities. Now, to some people, that is grossly offensive, and to some people, it is a very, very major problem. To others, it's a price of progress. And I am not going to fall down on either side of that because it's not my place as host to dive into that too deeply, but it's leading to a lot of discussion. But the problem is that the forces that are driving the expansion of this stuff are interested in their profits. They're accountable to their shareholders, not to different cultures around the globe. So you've got a growing friction there that is not just a friction between astronomers who want to see the night sky, but a friction that is across borders and across cultures. And you're getting this conflict and this discussion about who has the right to do these things, what the impact will be. Do we have, for example, a cultural heritage right to the moon that we've seen for generations to look the same for our grandchildren as it did to our grandparents? And they're questions that are being asked, the questions that policies attempted to be driven on, but the policy will not be determined by the astronomers or the archaeologists. It will be determined by politicians who will be influenced by the people who influence politicians. So it's going to be a really thorny problem. What's slightly heartening with that, though, is that we're having these discussions. If we don't discuss it, we won't have any impact on the answers. And if we discuss it and people get engaged and they're getting excited and energized on either side of the debate, that then creates pressure for the politicians to work on behalf of their constituents, which may help the process. I don't know, I try to be optimistic with these things, but it's asking questions like that. Should we have the McDonald's logo floating around the Earth so it passes over brighter than the International Space Station? Who should govern that? Who should have the right to hand out a license? Because licenses are given out by individual countries, not globally managed. So we were talking earlier on about Starlink. Starlink are proposing to put 42,000 satellites in orbit around the Earth in the next decade. The other proposals for mega constellations mean that there are currently 543,000 proposed satellites scheduled for launch in the next decade. Many of those won't launch because many of the companies are reserving slots for something they might do but probably can't. But they're lodging these things with different countries. If you say you're going to launch a mega constellation and you reserve it through France, America can't stop you doing it. There is no global oversight over these things. And that's where the space treaty is currently lacking, and it's why there's a lot of discussion and why people are trying to ask these questions. And why there are positions for people to do PhDs in this, to look at this interface between culture, archaeology, astronomy, commerce, there's a lot of unexplored space, and it is very much like the Wild West at the moment. So,
And I think you're right, Jonty, because things like what we're doing now, talking about space, what's going on in there, politicians respond to votes, pressure, and I think the better informed, I'll be honest, I'll give you some more background. I'm actually, as is Jonty, sort of deeply embedded in the Australian space industry community. I'm a former deputy chair of the Space Industry Association of Australia and currently on its council. But when I go outside that circle and say to people, they're going to mine the moon, most people I talk to are horrified by this. Absolutely horrified. But they're not aware of what's going on, or you hear news stories about stuff that are kind of contextualized quite differently. So you don't necessarily put them together in that sequence. So I think like if people are horrified by these proposals, you need to be informed and have some kind of sense of avenue for action, something you can do to say, well, actually, we don't like this, we don't approve of this. In the space world, people speak as if this is inevitable, absolutely inevitable. And the more they speak of it as inevitable, the more inevitable it becomes. And so we need counterplays, counter stories, counter movements. And maybe all they'll do is pull the current plans back to a more reasonable position. But if we don't do that, at some point, someone, likely the US, will make a territorial claim on the moon and say, you know, get stuffed out of space treaty. What are you going to do about it? And the answer will be, well, not a huge amount. And there, Australia is signed up to the Artemis Accords. But we're also a signatory to the Moon Agreement, which people will tell you is a failed treaty and don't pay any attention to it. But the various groups and committees I'm working with currently are all finding out that, in fact, the Moon Agreement isn't what they thought it was because nobody reads it. And so there's support is gathering for the Moon Agreement, which I think is really interesting.
I'd make one suggestion here. There are a lot of people out there who are concerned about behaviour of large corporations to the point where for pro-carbon conservative directors were tossed off the board of Australian Gaslight. We've seen other director actions where BHP wanted permission from their at the annual general meeting to raise finance for a coal mine, and the shareholders said no. The shareholders own the company. Now, what I have yet to see when people say things about the moon, and I've got friends who are quite hot under the collar about this, is you show me a valid business plan, and as soon as you've got a valid business plan, you're going to be reading that treaty in very, very fine detail. You're going to be reading it with very heavy lawyers. You're going to be going to investors, and the investors are going to look at it and say, no. So I think it's a self-regulating problem, provided there's enough education. And that's where Jonty's thing, people doing PhDs on this is really important. Because as soon as people start doing an official due diligence for a very expensive off-world mining operation, they'll find what you've got to say to them.
Question is whether they'll listen. I guess that's the hard part. But it is a fascinating discussion. What I would say, because I'm aware that people are sitting here listening very patiently, is maybe what we should do at this point is thank Alice once again for her time. And I want to invite those of you who want to continue the discussion to come down to the front and chat with us while we pack up. But that way, those of you who have other places to be don't have to be polite anymore. And I do really appreciate you all staying and keeping us company tonight. Just as a reminder, tomorrow is the final day of the festival, and we've got kind of a double bill of events that we do every year. We've got the Curious Kids panel, to which kids of all ages are welcome, but the younger kids are prioritised to ask their questions, of course. We'll have Alice, we'll have Graziella, last night's speaker, we'll have Dr. Belinda Nicholson, one of USQ's researchers there. I'll be emceeing it and also answering any of the questions that they don't want to. So good luck to me on that front. When that finishes, if the skies are clear, Roger and Robin, who are sat up near the back, will be there with telescopes out near the central driveway on the grass near the helipad. They'll do telescope observing while I stand out there and point at the stars and basically waffle and tell you some stories. So that's the plan for tomorrow. The Curious Kids panel begins at 5 p.m. If the skies are really clear, the panel will run till about 6:15. If it's cloudy, we'll just keep going, because if you can't see the stars, we can at least answer the questions. So thank you once again for your attendance and your attention, and hopefully see some of you tomorrow. Thank you.
Thanks everyone for having me.